So, what is entropy in chemistry? Well, entropy, with the symbol S, a capital S, is a term used to quantify the amount of disorder in a system. And in chemistry specifically, we are interested in how entropy changes, or how disorder changes, during a chemical reaction. So let's look at 3 different examples and identify which, in each case, has a greater amount of disorder. Firstly, let's consider the disorder in 2 states of matter, comparing a liquid and a gas. So, here is a particle diagram of a liquid. And in a liquid, we know that particles are moving around freely, but close together. Let's compare this to the particle diagram of a gas. In a gas, my particles are still moving around freely, but they are far apart and they are moving much faster because they have greater kinetic energy. So let's add some little arrows on both diagrams to represent their speed. So to compare the disorder in these 2 systems, I need to think about how many possible arrangements there are for the particles in each case. So in my liquid, my particles are moving slower and they are limited to a smaller area of space in the bottom of the container. This means there will be fewer possible arrangements of those particles in that space. In my gas, my particles are moving much faster and can also move around the full volume of the container they're in. This means there will be a much greater number of arrangements possible of those particles inside their container. So comparing these 2 states of matter, I would say that a liquid has a lower level of disorder, therefore lower entropy, whereas my gas has a higher level of disorder and so a greater degree of entropy. Let's now look at a second example. Let's take 2 substances that are identical and both in the gaseous state, but in the left-hand box I'm going to put 2 molecules and in the right-hand box I'm going to put 4 molecules. Again, to compare the disorder in these 2 containers, I want to consider how many possible arrangements there are for those particles in that space. And given that in the right-hand box there are twice as many particles, there are going to be many more possible arrangements in that box compared to the box on the left. Meaning that the box on the right will have a greater level of disorder than the box on the left. And with greater disorder, we see greater entropy. So if I'm comparing 2 substances in the gaseous state, the container with more molecules has a greater level of entropy. Let's now look at a third and final example. In this example, let's consider how entropy might change during a chemical reaction that releases energy to the surroundings. To do this, let's consider the movement of molecules in the air surrounding my chemical reaction before, during, and after. Let's draw a dish containing a fuel, which we are going to react with oxygen in the air in a combustion reaction. So the red particles are representing my fuel molecules. The purple particles represent the oxygen molecules in air, and the yellow particles are representing all of the other molecules that we would find in air. Let's now focus on the movement of the other molecules in the air represented by the yellow particles. Air is a gas, so those particles at this stage are going to be moving fairly quickly, and I can represent that by adding some arrows to the yellow particles. As soon as I light my fuel and it begins to react with oxygen in the air, it's going to start releasing energy to the extent that I will probably see a nice flame. So as my chemical reaction releases energy to the surroundings, my yellow particles are going to increase in their kinetic energy, meaning they are moving faster. So let's draw slightly larger arrows. Now as my molecules in the air start to move faster, we start to see an increased state of disorder, and therefore the level of entropy is increasing. And as I continue my reaction, more heat energy is being released, the kinetic energy of my molecules in air continues to increase, therefore my entropy continues to increase. So by the time my reaction has finished, my yellow air particles, or molecules in air, have much greater kinetic energy than before the reaction, therefore we have the highest state of entropy at that point. Let's now summarize the key points from this video. Firstly, entropy with the symbol S is a term used to quantify the amount of disorder in a system. In chemistry, we consider three characteristics of a chemical reaction to identify changes in entropy. The first one is the state of matter of my reactants or products. The second one is the number of particles in my reactants or products. And the third one is the energy change during the chemical reaction. And this is the basic knowledge required to understand entropy in chemistry. If you found the video helpful, you might like or comment, and you perhaps will even subscribe to the Cohesive Chemistry channel.